In this video, I'm going to show you how to customize an instant NFT with the P5 example that we provide. After you've created an instant NFT, this is what your screen should look like. You'll see this string called holder. This is just a placeholder string that we put in the contract. It just means that you haven't added any scripts to this instant NFT yet and haven't customized it yet. We give you a number of templates that you can use to get started, and we have four here now. There's three that are the p5, the 3.js, and the Babylon.js use JavaScript libraries, and then we have an on-chain one which will generate a 100% on-chain NFT. That's what we use for our YEPs, and I believe the example that gets loaded is similar to our YEPs. So let me just load the P5 scripts. I'll go into some detail about what's happening here. For now, I just want to scroll down. We have a debugger that's built in. So if we click the test, this is what the sample's doing. It's from one of the examples on the P5 website, just generating some particles. So first I want to talk about how the metadata is retrieved from an NFT and what usually happens and what we do that's different and we think makes it much more robust and a lot better. So every NFT has a method in the contract called token URI, and you pass in a token ID and it returns you a URI that you use to get the metadata for that NFT, and the metadata is in JSON format. So normally what's returned is just a URI to some server that will generate the JSON metadata. If you were to look at you can go to etherscan and look at the art blocks contract or any NFT for that matter, and you can look at the etherscan allows you to call methods. You can go to the read contract methods. You'll see the token URI function there, and if you plug in a valid token for that NFT, it will return you the token URI. And if you were to look at, say, art blocks, you'd see that it's just returning a string that's pointing to one of their backend servers. So that's how most NFTs work. They just return a URI to a string to a backend server. But there's a problem with that. That puts a strict dependence on that NFT now and forever into the future on those servers, whether they're there or not, and whether they're going to be up when you need the JSON metadata. So it's there's a small element of risk there, no matter where that URI points. So there's another way to generate the JSON metadata, and that is to return from the contract. You can return what's called a data URI. It's a URI, but it includes the entire payload for the JSON as part of the URI. So it doesn't have to call no one has to call an external server to get the data. It's generated directly from the contract on chain. So doing it this way, it gets rid of a dependency. You're only reliant on Ethereum in order to get the JSON metadata. So the reason that most NFTs don't generate the JSON metadata on chain is because you have to write code to do it. So you either have to write Solidity code, or you have to have something in there that's gonna generate that metadata for you. So what we've done at Instant NFT is we've created a programming language called Gyve, and it's a Lisp dialect, and it runs on chain. And it's a very general implementation of Lisp, but it can work for many use cases. But we've added a lot of specialized primitives specifically designed to generate the JSON metadata for NFTs. So this gives us enormous flexibility in generating the JSON metadata. We don't have to hard code anything in Solidity code. We have this programming language that we can use to specifically generate JSON metadata for NFTs. So OpenC has really defined what's called the metadata standard for NFTs, and so the JSON that you generate has to comply with that. It's fairly easy to comply with it. There's only a few fields that you need to add to your JSON. If I scroll down a little bit, you can see that we're adding in lines 21 through 24. These are adding some fields to the JSON metadata, and a few of these are required. Some of them aren't, and I'll go into more detail about specifically the animation URL one in a little bit here. But you can just see this is an example of one of the operators, primitives that we have in our Lisp that's running on chain, that's greater than ampersand. This adds some metadata to the JSON. So for a pure on-chain NFT, like this example up here that we have, everything is on-chain, and there's no reliance on anything other than the Ethereum blockchain. When you use P5 or some other external JavaScript library, or it doesn't even have to be JavaScript, but if you use one of those, you can almost get it 100% on chain. Not quite, but close, and that's the big difference that we have at Instant NFT. Because we can generate this JSON programmatically, we can come very close to getting, well actually in this case we do. You can get 100% of it, of your NFT on chain, with just a couple caveats, and the caveats are just revolve around how OpenC interprets a couple of the fields, the image data and this animation URL URI also. So there's two things that get displayed on OpenC. One is the image field, which we generate, like on line 7. We generate that through this, it's called a stream operator, and I'll talk about that in a minute. And then the other one that will cause a display on OpenC is this animation URL. So the image is restricted to just, it has to be image data and pings or SVGs, but the animation URL can be an HTML, payload. So that's why if you look at art blocks, for example, many of the art blocks projects, when you're looking at the list of NFTs for a project, you'll just see the image data, but then when you click it, you can see that you'll see the actual algorithm running. Many of those they're 3.js and p5, most of them I think. But you actually see the algorithms start running, and that's because they do something similar to what we're doing here. Is they return an animation URL which can point to HTML data, and they embed that in an iframe on the page. So you can see we're just setting what look like typical URLs to some, something on our backend server that we have, and we really don't have a choice in this case. You can't return a data URI for this animation URL. It doesn't work properly. It has to do with the way OpenC copies it to their server, but it just doesn't work properly. So we're restricted to having this reside somewhere outside, it's on some external server. But the thing that we do that's different is you can see here that we're generating some HTML on lines 9 through 19, and I'll explain how that works in a little bit. But that's getting, you can see this on line 3 we have this generated URL string, and that's setting the name of the field in the JSON that we want to add this HTML data to. So when this JSON is generated, it will generate another one field called the generated URL, and that's going to be a data URL that contains this entire payload. So OpenC isn't using that field, but if you were to go to etherscan, like I said before, where you can put in a URI, a token ID for the token URI function, if you did that for one of our NFTs, it's not going to return just a URI string. It's going to return a big payload. It's base 64, a large payload with all this data in it that we're generating here. So you could actually take that JSON payload and paste it into a browser bar and look at it. And what you'll see is you'll see the fields come up: the animation URL, external URL, name, description. But you'll also see one called generated URL, and that's going to have this payload, this HTML payload, and that itself is another data. It's another data URI. And if you were to take that field, this generated URL field, out of the JSON that you see after you pasted it into your browser, if you copied that field and pasted that into into a browser also, you'll see your whole P5 algorithm running, because it's going to generate the actual HTML. And so what you'll see is your P5, your entire P5 algorithm running. So in that regard, we do eliminate any dependency on us on any backend server, because you can get all the data, 100% of the data, and run it directly in your browser right from the blockchain. You can do it via etherscan, or there's other ways to do it. Now, when we integrate this metadata into OpenC or whoever else is interpreting it, we have to do a couple of things a little bit different. One is we have to give them this animation URL, and that has to point to something on an external server. And it's the same with the image URL. This is used for the thumbnails. That has to get generated somehow too. We're restricted in doing it that way. That's how NFTs work. But for the animation URL, for example, all we have to do on our back end is copy this generated URL directly. So we're not adding anything more to the HTML that's getting generated from this guide script. We just have to copy it directly, and then it has to point to this URL that's on line 21. So by doing it this way, we're eliminating any dependency on any external server, including ours. So it's obviously that's something that you want. You don't know how long a company's going to last, or so. And in this case, you don't have to really worry about it, because all the data is going to be on chain. I'm going to cut this video off now. It's approaching 15 minutes. I don't want to go over that, and I'll continue it in part 2.